So anyhow, I'm making one video kind of combining everything together here. Just giving you an update here and showing you real quick a cool experiment here that I'm playing around with. I've been trying a lot with the boosting the voltages. We're going to try multiple methods to boost this voltage up until we find the right one, at least. Alright, we'll be right back. Oh, right off the bat, I'm having all kinds of problems. Alright, so I found a way to check the voltage and my frequency generator. It's 14 volts. There's a 12 volts, my frequency generator that's being applied. There's the negative goes to nothing. There's the positive to the two diodes. Goes to the ceramic disc capacitor. It's very small. But now we're getting almost 8.5 volts. Okay, we're still applying 12. But now, let me show you something else. This wire goes to earth ground. Just a 1/4-inch diameter copper rod. I got about 1.5 feet deep in the earth. I use this for many experiments. Anyhow, watch what happens. Oh, hold on. I clipped that on there. $64 volts. Interesting, right? Okay, I replaced those two. This is 1N4148, I believe. Fast switching diodes. This is a standard good old Radio Shack. 1.5 volt, 1000 or 1.5 amp, 1000 volt silicon type diode, and you can see I'm applying 12 volts. We're one end of the transformer here. We got like 25 feet there, like 50 feet here. So it's double the amount of windings. Almost. Oh, look at this. I don't know whose cat that is. It just came into my laboratory. Oh, you don't look wild. You don't have a collar. You got a cool face. Come here. You're digging around everything, huh? Huh? Yeah, he's cool looking. Anyhow. I think I just made a friend. Yeah, we only need one wire. You don't have to have connections on these. It's a beautiful, beautiful thing. I've done these, worked with coils like this many times in the past. Energy transfers right from one to the other. You don't need the other end connected. Anyhow, you come out here, come out to two diodes, come out to our capacitor, and we got like 11 volts there. Not the full 12 volts, so we're losing a little bit of energy. But, alright, so it's showing it's working, it's transferring energy, but we're not doubling the voltage. We're not boosting the voltage. So, it's, hey, oh, wait, nah, you can't go up here. I'm gonna have to kick her out, kick her off the table here. There she goes. Alright, so we got to put this in some other area. Yeah, that's a beautiful cat. It's got to belong to somebody. It's too clean. As soon as I turned on my jet heater, it darted out of here pretty quick. Using both sides, connecting up here, adjust the positive, and now we connect our positive negative meter, and do have like 40 volts there. If I connect an earth ground here or here, surprisingly, it does add another 10 volts. Let's see, I might try this one yet here, this setup with this guy yet. Now, yeah, hang on one second. So I'm gonna figure something out. I will. I'm gonna figure something out. Let me show you this little setup here. I've got like a loop going on, and it's basically coil, LEDs, another diode, to a capacitor, and the bulb is in parallel or across that capacitor, and back there's another diode back to the coil, and I'm feeding it energy from the frequency generator. You know my schematics, guys. Anyhow, I got a loop. It's basically a coil, LEDs, and capacitor, and a bulb across the capacitor. And over here, yeah, all these LEDs are blinding. Bulbs are okay. I just want to show you this. Now, yeah, I had to put it up on a little piece of board here. Now this loop, and I had to work, I still don't think they're exactly the same, but this is another identical loop. Coil, LEDs, capacitor, bulb across it. Thing is, the capacitors, you know, they're plus or minus 5%, so they're not exactly. LEDs aren't exactly the same resistances. The diodes aren't exactly the same resistances or same voltage. You know what I mean? Everything across them, same junctions. Anyhow, but anyhow, I got them very close. One loop and the other loop, and I'm powering one of the loops. This loop is wireless. So these LEDs and this bulb is lighting up from the energy off of this coil. So, and I've even had better results with the pancake coil here, and then a bunch of little miniature coils under it and even above it. But this is just something I'm playing around with right now. There's 124 volts. Whoop. 124 volts across this one. And this is the one that's picking up the energy. So this is really cool, you know. I want to get this working better too. And I'm still thinking a lot about this. I could build a motor, but then it has to be a different type of motor than we're used to. Right now I'm at 2.6 megahertz, 20 volts, and again, the most this could put out per the manufacturer is only 100 milliamps, so that's at the most 2 watts. And I know I don't have exactly 2 watts going to the system, but anyhow, it's probably less. Now I'm going to go up, you can see where my cursor is, I'm going to go up 10 kilohertz at a time. I'm going to go 2.610. Let me show you this real quick. 2.610, 2.620, 2.630. Oh, there goes the left side. 2.640. Getting brighter. 2.650 or 40, 50. Haha. So you can see how that gets even brighter over at that side then. I don't have the meter connected to that side, but hang on. Alright, let's go back. Oh, 2.650. Let's go back where we started, and now we're going to go this way. 2.590. Hold on. Let me show you what happens. 2.590. Wait a minute. Go back to 2.6. Hang on. 2.6. Wait a second. There it goes. The voltage was... Oh, now I'm getting too close to the coil. Hold on. There it goes. There it goes. There it goes. Okay. Alright, I had to wait. Okay. Now, 2.590. 2.580. Now you can see this side's getting brighter. 2.580, 570, 60. Isn't that interesting? Now you can see I still got 125.5 volts across that one. And it's like, wait a minute, that one's picking up that one's energy. This is the one that's just wireless. And if we keep going, 2.550, 2.540, 530. Oh, there we go. 520, 2.510. Oh, there we go. Now, yeah. 510. That's it. I'm not changing anymore. Now we're at 2.510. Now because of the capacitors, I'm not changing anything now. I've seen this effect many times in my system too. I gotta get these much farther apart too. Anyhow guys, having lots of fun. And of course we're gonna change the world here. We're gonna get this figured out soon here. I don't live forever. Nobody lives forever, man. And I got to get on a roll with this stuff. This is going to happen. This is going to happen, man. Alright, so just real quick. We got about 126, over 126 volts each bulb. Across each bulb there. Plus these blinding LEDs here. You could see only 20 volts, 100 milliamps at the most, 2.66 megahertz. Oh yeah, if we go down here too, I also have some LEDs there that are, that's a piece of styrofoam you're looking at there. No big deal. I just have a string of diodes connected in parallel with those LEDs, and those diodes are near my secret sauce. No big deal. No. I've showed you guys the circuit. So, one loop. is picking up the energy from this one. Now if I were to disconnect one loop, instead of over 126, I'd have over 129. So it does rob it of its energy. But there's a lot of fine tuning involved. As I said, LEDs are not perfectly matched. Capacitors are not perfectly matched. Diodes aren't perfectly matched. That's why Tesla wanted everything perfectly matched. I'm starting to see that and understand the importance of that. Wow. Look at the brightness of these LEDs on me, man. Wow. And the bulbs. LEDs and bulbs. Wow. So just wanted to show you this real quick. It's really raining outside. Excuse the noise. There's those LEDs there. Very bright. Plus I got this is like a 100 watt LED panel light fixture. Well, that's a 100 watt strip there. 100 watt strip on the other side. They went bad because of a tree fell over on a power line, and we had one of our 3 phases in the building burned out. So anyhow, I got a bunch of free fixtures like this. Basically, a lot of the ballast, I think, burned out though. Alright, one more time. Oh my god, my eyes. Yeah, cool, cool. See you guys later. See you real soon. Wow, it's really raining outside.